Scilab, free software for numerical computation. Okay, why do we need to have something like Scilab? It's very simple. In the old times, in the 80s, when we wanted to make, for instance, a matrix computation, like this one, two matrices, a second member, and we want to know what is X. What can we do in 1980? It's very simple. You only have to write a Fortran code program. You know Fortran, the language that was very, very old and that is still used today. So you see, with this program, you only have to punch cards and to put them in the machine and wait for 1 hour that the mainframe give the answer, or later put it in a file and send it to the mainframe. After 1980, people write software doing this in very easy form. As you can see, you read A and B, and X equal A multiplied by A backslash since solution of a linear system B. When I told this story to people today, and they see X equal and so on, they say, hey, it's normal. Hey, yes, it's normal. But in the 80s, it was not normal at all. And it was really a revolution in order to make matrix computation. And with this kind of paradigm, kind of program, software existed, MATLAB, well known, Scilab, Octavie, and perhaps other programs. Okay, so this is the story why we need something like Scilab. But in fact, what is Scilab? Is it a language? Is it a software? What is it? I'm going to tell you by explaining you what are the guts of Scilab, what there is in it. About functionality, external functionality, Scilab is more than 2,000 functions in all domains of applied mathematics, numerical analysis, and so on. More than that, it has something we call XCOS, which hybrid dynamical system modeler and simulator, which allow to graphically use the block diagram paradigm to make computation in automatic control, which is very important because this is the same thing as Simulink in MATLAB. Very important because if you don't have this thing, people are using Simulink are not going to use Scilab. So it's very, very important. You have also graphics, graphical user interface, and help, an editor to write programs, and a language, that's okay, and an interpreter. And more than that, a number of contributors. Because as we are free software, it's easier for us to have many contributors that give the source code. So you can see here a number of external modules for video processing, for many things. And this is very important in the model we have, the model of having open source and the help of a community to add functionality. Because in Scilab, the Scilab organization is not 100 people. This is the vision of what you can do with Scilab. But in fact, what is there in the interiors of Scilab that permits to do that? There are computation libraries, Fortran C code, a number of lines, many lines, and Scilab code, because a big part of Scilab is written in Scilab language, which is a very well and simple language to understand. These are the computation library. They are linked to the parser and the interpreter, to the graphics, the graphic user interface, which is written in Java, parser interpreter in C++, And in front of this, you have a user. The user don't see anything. They don't have to see anything. And on the part on the right, you have a documentation, very painful, pen tasking thing, very complicated to do, but very important. And this documentation is in XML. So this is what there is in the Scilab, the Scilab today, the Scilab 6, who changed a lot from the old Scilab 1.1 in 1994. But this is normal. And now we have a software for numerical computation who has all the functionality that you need, language, and it is ergonomic.